So I'm Jaqui Mills. I'm a senior solution architect in a team called Digital Grid, which really means that we work on the software part of Schneider and within power system control room software. On stage, I'm joined by Cheryl and Michael from SAPN. If you want to introduce yourselves quickly.
Hi everyone. So I've been with SA Power Networks for about 5 years. I work as an ADMS operations engineer in the network optimization and security team. So I basically at the moment looked after a lot of our DERMS. You'll hear a bit more about it later. Our DERMS project, as well as other sort of automations and ADMS modules.
I'm Michael Brown. I've been with SAPN for about 5 years full-time. Again, 5 years as a contractor before that. I am in Cheryl's team in network optimization and security as a distributed energy systems engineer, so focusing on the operational systems that control a heap of our distributed energy resources on the network.
Awesome. So what we're going to take you through is I'm going to kickstart with some trends, and then I'll be handing over to Cheryl to take you through a bit of an overview on South Australia Power Networks, their road behind. She will then hand over to Mike to go through the road ahead and summary and some key takeaways. All right, so here at Schneider Electric, we talk about E plus 3D, which translates to electrification, digitalisation, decarbonisation and decentralisation. And there's more of all of these. These are not necessarily new trends anymore, but certainly we continue to track them, and this is driving a lot of the changes that we have, certainly in Australia. So as we transfer away from gas in our homes to more electric, to electric cars, to having more data coming out of our ears and perhaps not sure what to do with it and making sense of it, more decarbonisation as we work towards our net zero targets globally, and more decentralisation as we take on more and more solar in people's homes and batteries and electric vehicles. Here in Australia, we are world leading in a lot of these figures. So in the middle there, over last year alone, there was 2 gigawatts of rooftop solar added to the national electricity market. And in quarter 4 last year, 2024, 20% of the NEMS generation was met from rooftop solar alone. So there's a lot happening. This is fundamentally changing how the medium voltage and low voltage part of the network works. And to keep an eye on all of this, the Australian government has released a consumer energy resource roadmap. It was released in July last year. I've then highlighted the key elements in the green boxes for the distribution utilities specifically to be conscious of. So they're around enabling more flexible connections, allowing more EVs to be easily connected and removing the barriers, having a backstop mechanism. Because of the amount of solar I just showed you on the previous slide, we actually have minimum demand issues here in Australia, which is fairly unique, and at times to make sure that we have the right supply-demand mix, AMO is then coming in to, at times, restrict the amount of solar coming into the network from households, and lucky last, towards 2030, have more smart meters so that we can actually see what's going on in the LV grid. So noting all these changes and the amount of solar coming in, we thought who better to invite to stage is SAPN, a long-term client of Schneider Electric, and they'll be going through their digitisation journey over the last 10 years. So before I steal any more of the thunder, please invite Cheryl to the stage.
Thanks, Jackie. Oh, thanks, everyone. So, as I mentioned before, Michael and I are from SA Power Networks, or SAPN, as we like to kind of nickname it. So we're firmly in the distribution space in the electrical supply chain, as you can see there, and we're one of the world's highest rooftop solar penetration in South Australia. So that puts us very uniquely to be the world's first 100% renewable grid. Move on. Here's a quick little snapshot, just to give you more context of what SA Power Networks network looks like. So we've got 900,000 customers, and we've got thousands and thousands of kilometers of line. And some parts of the network are extremely long and extremely stringy. So we've got some feeders, for example, single wire earth return feeders that are tens of kilometers long that supply perhaps only 2 customers at the end of line. So you can imagine our network's very, very vastly spread out, very, very long and very stringy, coupled with the fact that we now are capable of supplying 100% of our state's demand on low demand days we're definitely under pressure to modernize our control systems to keep up with with this energy transition. So let's have a look at how we've been handling it so far. I'll have a look at, excuse me. There we go, back again. So here's our road behind our journey thus far with digitalization. In 2015, we replaced our SCADA systems and SCADA interface systems with ADMS, Schneider Electric's ADMS, which allowed us in 2017 to import our HV and LV model fully, integrate our GIS, and open the doors for digital switching. These are all really fundamental projects in the foundation horizon. We're talking a lot in this presentation about foundation, automation, and optimization because we believe these are the three, I suppose, key horizons that everyone should be on or looking towards the next horizon for, should be on this journey. Now, in 2017, we also started exploring our first new ADMS module called FLISA. Those keynote among you might have heard about it, but essentially it stands for Fault Location, Isolation, Supply Restoration. You'll hear a bit more about it from me in a few. But we started playing with it in 2017, started it on advisory mode. Basically, we gathered all of our data, built confidence in our business in 2017, and in 2018, we finally implemented FLISA in auto restoration mode. It's been running since then to this day, so nothing's broken so far. It's been amazing. That opened the door for state estimation tuning because FLISA and state estimation go very much hand in hand. And I'd be remiss not to mention one of our other larger projects, OMS, Outage Management System, also integrated in ADMS, the ADMS environment. OMS is basically, it allows us to efficiently handle outages in all one centralized location. So I'll speak a bit more about some of these major projects in a few. Okay. That was our very brief snapshot of our road behind, but I guess why did we even start on this journey? Let's have a look. Over the years, we've trended our expectations from our target expectations as well as our performance over the years, and we've noticed a very clear trend. So I don't know if you can see the text very clearly, but the top basically states average customer outage duration, and the bottom is average customer outage frequency. So essentially over the years, you can see every regulatory period, our targets have been decreasing, which means really that's a reflection of increasing customer expectations as well as increasing regulatory pressures. This means we really need to be on our game and striving constantly to be more efficient. Basically, this is why we started on building our foundations. So we're modernizing our control systems back in 2015. This is what it really looked like before. We sent people out to field, as per usual, but this was a really arduous and laborious process because you would have to write every single switching program by hand. Any sort of changes will need to be very meticulously highlighted, and then it would have to go through a whole chain of people to really reach the field crew in time. You can imagine it's very time inefficient, causes our controllers to lose a lot of hair as well, so not the best. We could always do a bit better. And here comes ADMS. There we go. So you can see there, our controllers now sit in a control room like this with our ADMS screens up in front of them. They can now create switching plans pretty much by dragging and dropping, clicking a few buttons. They can also validate their switching plans now, which basically allows us to check if we're de-energizing any customers that really should not be de-energized. And everything is just a lot more efficient and a lot more streamlined for the sake of our controllers and our customers. I don't want to, I guess, undersell the importance of building your foundations there. I think even if you're not started on the digital switching journey, it is very important to be looking to these sorts of systems because it is the next step in the future, the next step to maintain reliability in your network going forwards. So once we had all of that foundation, our next big picture goal in SAPN was to look into the automation space. And as I mentioned before, FLISA was one of the first modules in the ADMS suite that we implemented. So FLISA, as I mentioned, stands for Fault Location, Isolation, Supply Restoration. And essentially, as you can see there, it is a centralized system designed to automatically restore supply to healthy portions of the feeder in a fault event in under 1 minute. And I can go on about the drivers for Flizzr, but essentially you can probably see the stats speak for themselves. We've got 300 feeders so far, Flizzr enabled, and across the years, we had 1,200 odd Flizzr events on those feeders, and of those events, 86% of them have had some sort of restoration benefit returned to us. 80% of that was a full restoration. 6% was partial. So you can see that. Now, I've spoken a tiny bit about all of our journey behind, but let's look at what's happening across the next few years. I'll hand over to my colleague Michael to bring us a bit further into this.
All right, thank you, Cheryl. So looking at the road ahead, we're really wanting to get into the optimization space. So when I talk about optimization, I mean increasing our network utilization, so more energy throughput for our existing network without having to augment the network, reducing costs for us and reducing costs for customers. So a couple of the big things that we're doing in this space is our DERMS project, which I'll talk a bit more about in a minute, and Volt-VAR optimization, so adjusting network equipment controls to better facilitate more load and generation on the network. We're still very much looking into foundation and automation space as well. That's something that's definitely not going away. Couple things that we have done and are continuing to do. In 2024, we've had the ADMS upgrade project. We've upgraded our Schneider ADMS version from 3.6 to 3.9. And next year, also 2025 this year, we'll be doing it again as we move to keep up to date. We have started to implement LV switching. We've digitized our HV switching process. We're now doing the same thing with LV switching. We've got LV state estimation tuning coming, fire mitigation tool, wide area restoration, and more. So South Australia are in a really unique position. As Cheryl mentioned, we've got a very long, stringy network. We're the only distribution network service provider in South Australia, so we service all customers. We also have fairly low load demand, energy consumption for the people here. But we do have a huge amount of renewable penetration. This graph here shows the energy nameplate capacity for some of the larger generators in South Australia by fuel mix. You can see on the right-hand side, rooftop solar is by far the biggest generator when you put all of it together at 2.8 gigawatts. This obviously causes some challenges, one being network constraints, particularly on the LV. We're seeing higher voltages on the LV caused by rooftop solar. We're also seeing transformers being put at risk of thermal constraints, of hitting their thermal constraints, as we see a lot of reverse flow up these areas. We had this sort of issue 10 to 15 years ago with high amounts of aircon uptake. We're now seeing it in the generation space, but go in the opposite direction. We also have a responsibility to maintain system security. AEMO obviously need a certain type of generation mix to keep the system secure, resilient to faults and disturbances. Large synchronous generators are great for that. Rooftop solar, not so much, which is again why people or DNSPs are putting in remote disconnect backstop mechanisms. That's something that we did implement in 2020. So from 2020 onwards, all inverters that are installed in South Australia need to be remotely able to disconnect via the internet. So looking at more permanent solutions to this, we've introduced flexible exports, which is a new connection option where customers can choose a flexible connection between 1.5 to 10 kilowatts per phase. And this is something that we update dynamically dependent on network constraints specific to this customer, and we update them via the internet. We also have the Energy Masters trial, which is something we're completing at the moment, where customers can opt in to receive import limits in addition to export limits, completing the dynamic operating envelope for equipment. And this will apply to some of the larger loads like batteries, EVs, and hot water systems. So this can make them responsive to network constraints, plus also market pricing as well. We do have a presentation by one of my colleagues, Sam, in room 3.5 directly after this one. So if you're interested in energy masters and HEMS in general, definitely recommend going to see that. So this brings us to our DER management system, which is a Schneider product that we're currently implementing. And this is to replace the constraints, generation and control generation functions of flexible exports that we have now, which is really great because it's designed to be scalable right from the get-go. When we finalise implementation, it should be able to support 300,000 devices, which we're really excited for. In addition to that, it has visibility of all the other things that's going on in the ADMS, so all the large SCADA-enabled generators, both existing and future, so we can start offering flexible connections to those larger generators too. So in summary, the 3 areas that we're really focusing on are the foundation, as Cheryl mentioned before, along with automating things to free up operators to do more valuable work where their skill sets are needed, and then optimization to better utilise our existing network and defer augmentation costs. All this stuff is really great for operational efficiency. Obviously, moving away from paper-based switching just to digital switching is a big one. Cheryl mentioned before the benefits of FLISA, which have been massive for reducing customer impact during outages. But there's also a safety component. We're seeing more and more severe weather. And intelligently using our control systems, we can really mitigate risk to customers. SA Power Networks are also really committed to the energy transition too. We see us as a DNSP being a core enabler for the energy transition. And given the unique scenarios that Australia face, we are seeing a lot of the challenges that are arising from the energy transition a lot earlier than other countries. So I think us and other network service providers are in a really good position to be able to be good leaders in this space. Thank you.